Hello, welcome everybody. Here is your instructional unit 5.4 on degrees and radians. Real quickly, I want to show you what a radian is equal to. Pi, which is our normal 3.1415 number, is the same as 180 degrees, or 2 pi is the same as 360 degrees. So you can use either one of these as a conversion when you're converting from degrees to radians or radians to degrees. Why, you're probably wondering, like, what is a radian? A radian has a root word of radius, and it's related to the radius of a circle. So if you had a circle, and the circumference of the circle has a formula of 2 pi r, that formula you should have memorized from a long time ago, like 6th or 7th grade math. Circumference is 2 pi r. What does circumference mean? Circumference means if I'm a little animal here and I'm walking on the outside of like a well or some sort of circular object, and I walk all the way around, that's what circumference is. It's the distance around a circle. It's kind of like perimeter, except perimeter deals with straight shapes, and circumference is a special word that deals with only circular shapes. Now, if I had a circle here and its radius was 1, then the circumference of the circle would be 2 times pi times 1, which is equal to 2 pi. Now, if you think about it for a moment, if you take one full spin all the way around a circle, hopefully you know that that is the same as 360 degrees. 360 degrees is the angle measure. If I take all these angles in here and go all the way around, one full turn gives me 360 degrees. Well, that's the same as the walking around the outside, and radian, even though it's a measurement of angle measure, it's also kind of like related to a length. If I cut this right here and straighten it out to be one long stick, like let's just say there's a string around the outside, cut it right here and spread it out, the length of this would be 2 pi. Well, why is that? Because that's circumference, 2 pi times 1, if the radius was 1. So that's how these two things are related. That's how you get this conversion. Now, you can use this conversion if you'd like, but if you divide both sides by 2, it's a little bit easier to take 360 divided by 2 and get 180, and use this conversion of pi is the same as 180 degrees. Now, I'm going to squeeze in 2 examples here. Here's example number 1. Let's say I had 30-degree angle, and a 30-degree angle, if I'm thinking about it on a circle, is this amount right here on a full circle. 30 degrees is that amount right there. 30 degrees, if I want to know how many radians that is, like how radians means like how long you'd have to walk on this outside arc, then I would take this and multiply it by pi divided by 180. Now, why did I do that? Because degrees is on the top, degrees here is on the bottom, and the degrees cancel, and I'm left with pi radians. It's a conversion. It's kind of like feet per second. So if I take this and I go 30 divided by 180 on my calculator and reduce that, change it into a fraction, I get 1/6. So 30 over 180 is the same as 3/18, which is the same as 1/6 pi, or pi over 6. That's how you do it. So when you're converting from degrees, you use this multiplier of pi divided by 180. Now let's say I started with pi over 6, and I wanted to go to radians, or convert, just like feet can be converted into inches. I would then multiply by the reciprocal of this boxed item, which would be 180 divided by pi. So you always want the pi's to cancel, because the pi's represent radians. So then you get 180 divided by 6, and 180 divided by 6 is 30. Oh, I didn't want radians in the end. I started with radians. I wanted degrees. Sorry about that. So there you go. That's how you figure out your conversion. If you start with degrees, you multiply it by pi over 180. If you start with radians, you multiply it by 180 over pi. Just a formula, that's all you need to know. Now for the second part here, now we're going to talk about arc length. Arc length can be thought of many different ways, but if you have a circle and you want to find the length from, let's say, here to here, how many feet is that? How many inches is that? You need radians to figure that out. Arc length is a special formula. Arc length is usually defined by S. I don't know why they use the letter S, but they do. And they just take the angle measure and they multiply it by the radius. R is the radius. Of a circle. So you're going to need to know how big that circle is, because if it's a bigger circle, you need that number to affect how long the arc is. And this theta, that's a Greek symbol for an angle, and the theta represents the angle that you moved, but the key is this must be in radians or it won't work with this formula. So if I started, this is example number 2. If I started and went, let's say, my angle change is going to be, I'm just going to make up a number here, let's say pi divided by 4. That's radians. Don't forget, pi will have radians, radians will have pi in it. Let's say I went pi radians around the circle, pi over 4. Now if I wanted to find the arc length, all I needed was the radius of the circle. Let's say the circle is 3 feet wide. All I would do for the arc length is use this formula and take our radians, pi over 4, multiplied it by our radius, which is 3. My answer would then be 3 pi divided by 4. Now, 3 pi divided by 4 is a weird number, so you could actually plug that into your calculator, and you would actually be able to have nice, beautiful number of feet. It's not really beautiful because it's a decimal, so it's 2.35 feet, because this was in feet. Now, the only problem with doing this is that if your angle measure is not in radians, you have to convert first. So let's say I didn't start with this, I started with 45 degrees. Now I know that pi over 4 is the same as 45, but let me show you how I'd do it. Just like the last problem, I'd start with 45 and I'd multiply that by pi over 180. I would get 45 pi divided by 180, and 45 divided by 180, and if I reduce that, would be 1/4. That would be 1 pi divided by 4. That would be the only step I would need prior to just doing my degree measure, radian measure, times radius. One last problem, number 3. What happens if you're trying to find the area of some sort of shape that's part of a circle? So let's say I have my circle here, and I have a piece of like pi cut out of there, and I wanted to know how much material it would be for me to make this object. It could be a painting, and how much paint would I need? It could be, I might be sewing with material, and it's kind of like a pizza wedge. How much material do I need? That's an area problem. Well, area problems for like rectangles is length times width. Area problems for circles is pi r squared. Area problems for triangles is 1/2 base times height. Well, for a sector, it also has an area formula. The area formula of a sector is 1/2 the radius squared times theta. Once again, r is radius, and theta is the angle measure in radians. To use these formulas, you have to be, that says radians. It's hard to squeeze that in there with a stylus. So if I had a problem like this and I needed to find the area of this blue section right here, and I knew that the radius here was 3 inches or something like that, and I knew that this angle measure here was pi over 8, I would just put the pi over 8 in for the theta. I would then put the 3 in for the radius, and then I would figure out this formula. So 3 is 9, so it would be 9 divided by 2 times 8 is 16. 16 pi. This would be the area of this blue section. Thanks for listening.